Good evening, YouTube. My name is Yusuf and you are watching my news channel. This is the second video that I make of a CME impact which started at around 6 UTC. So this is the initial impact. If you look at the BZ component, we see it tilting southwards, and this has sparked beautiful auroras, and I will show this in a moment. Also, this triggered a KP7, so a geomagnetic storm level 3, which is ongoing. If you look at the phi angle, we see the solar wind coming from different directions in blue, as you can see. When we look at the density in orange, we see also several spikes, but also dips in density, and spikes again. The speed is relatively stable, hovering at around 400 kilometers a second, and so is the temperature. I don't see any major fluctuations. If you look at the KP index, as I already mentioned it, we have a KP7, and it goes really fast. I mean, it jumps from a KP1 to a KP4 to a KP7. This usually indicates that the shock is pretty intense, and it was intense, ladies and gentlemen. In part, so the main reason is that dip in the BZ component, because it allows energy to enter our planet more easily, but also because of something else, which I will show in a moment. But let's just take a look at the auroral activity. Let me just go straight. So we did have briefly a rise in intensity, which is clearly visible, but it didn't really last long. So I'm not sure if we will have this again, a rise in intensity. It all depends whether the CME is actually over or not. At the moment it is currently ongoing, but I can't tell you when it will actually end. What I can show you is the intensity actually of that ongoing impact. So that CME is clearly buffeting our magnetosphere, and it is inducing magnetism at ground level. And this in curves has induced ground level currents, which I will show in an instant. So again, let's this is a global map. This was from the northern hemisphere, and there is also a map of the southern hemisphere. And don't forget that every single one of those links can be found in my web links. This actually can easily be found in the Space Weather Prediction Center. So, as I said, there are of course consequently ground-induced currents. And this basically means that all that magnetic interaction at ground level actually overloads the cables of the grid. And they basically induce a current in the cables, and this could potentially overload the transformators in the power facilities. If we look at the scale, we see that it actually jumps each time a factor of 10. So if it ever reaches the purple section, there is reason for concern. It may cause blackouts in the regions that are actually in this color scheme, because then it would suddenly jump from 100 to 1000 millivolts per kilometer. So this is something to look out. So yes, the space weather scale. So basically a KP7 is a geomagnetic level 3 storm. I'm going to read a little bit what it actually implies. So for the power systems, as I said, voltage corrections may be required, false alarms triggered on some protection devices, nothing major, nothing dangerous. Corrections might be needed in spacecraft and other systems as well. I'm seeing here intermittent satellite navigation like GPS and stuff like that, low frequency radio navigations, etc., etc. And of course auroral activity, which can be seen at typically 50 degrees of geomagnetic latitude. So this happens actually 200 times per cycle, and one cycle equals 11 years. So if you are interested actually in these scales, I will leave a link below as usual whenever there is a geomagnetic storm, so you can actually view this at your leisure. There are actually 3 scales: the geomagnetic scale, the geomagnetic storm scale, the solar radiation storms scale, and the radio blackouts. The ones that is of interest now is the geomagnetic storm, of course, because this is associated with a CME and with a rise in KP index. Radio blackouts are typically caused by solar flares, and I do believe so are solar radiation storms, because now we are talking about radiation that's usually caused by sunspot activity. So let's move on to the next, and this is actually quite interesting. Unfortunately, like I already said, there is of course again data missing, and I'm going to go back until actually to show you this is really not nice from NASA, and I don't understand the point of it. I mean, so let's go back quickly. As you can see, there's a lot happening. I will cover that in a moment. There we are. So for UTC, strangely enough, 2 hours before the impact is at 6 UTC, but now you will see the blackout goes from 4 to 8. So the initial impact is completely lost. We can't see it, and I mentioned this in my first video. This is really sad. But as you can see, something clearly happened, because instantly it goes to geosynchronous orbit. So for us, it would have been interesting to see what had actually happened. So let's move forward. As we are seeing, so something happened, and I started to see fluctuations, but most of all an opening in the bow shock and the appearance of what appears to be a second one. So yes, this is the point of interest, because now you can clearly see that actually the inner electron belt sort of connects with the front of the bow shock, and the pressure disappears. So whether this is energy that gets siphoned to the Van Allen belts, I don't know, but it seems that way. This is visible in all the simulations. If we look here at the magnetosphere simulation, we can also see this. Let me just go back to that particular timestamp. We're almost there. And I think I have to go back a little bit, but actually you can already see where this is going. So you see the closed field lines are expanding in a bubble. This usually doesn't happen from the backside. Oh, let me just go back a little bit. And this happens when actually the IMF started increasing a lot. So whether it is the IMF that increases conductivity and causes this, that's possible, but I don't believe, because it happens even when there is no space weather conditions going on. So that's just happening by chance. So what we can see actually over here, this is the exact timestamp, is actually a concentrations at the front side. This is this. Of the closed field lines, and as you can see, they are almost like fused with the bow shock, and this is exactly what's happening over here. So it shows up on all the simulations. Either here actually you can see it as an increase in intensity. When that happened, let me just, oh yeah, this is 8, we have to go a little bit further. So as you can see, it will suddenly go completely red in that exact timestamp, as you can see. And in my opinion, this is not a normal situation. But you see, this is not a glitch, because some people might be tempted to tell you, oh, this is just a glitch. I heard it so many times, but it is not, because its effect can be seen clearly. And a glitch would simply be if there's, for example, something which is impossible, like a big black dot, I don't know, something, a change, something which couldn't be happening. But this is clearly just something that happens, like closed field lines getting expanded here, concentrating over there. So this can be dismissed as a glitch, because it isn't. So yeah, I do think the Van Allen belts are causing this. Maybe it is weakening, maybe it is part of a cycle, who knows. Next, yeah, there was a C flare at 9.30 UTC and consequently a small radio blackout at the same time. So there you have it. Now, before I end the video, don't forget to subscribe and hit the like button and turn on the notifications if you subscribe. This way you won't miss any future content. Yes, just a little reminder. So this is sunspot 2822 and it has a delta classification. I wanted to show this again to remind people this is still an active sunspot and it has a long way to go before it exits the visible side of the solar disk. The other sunspot doesn't really have that complexity nor the intensity of sunspot 2822. I don't expect much activity from this one, but this is definitely something we should be monitoring. Earthquake wise, I have predicted an increase and it is happening. There was a 5.9 in El Salvador. There is a 6.7 going in the Mauritius Reunion Region, probably islands. And I do expect actually a 7-pointer at some point. This is definitely a possibility, especially if that KP7 persists. But we will have to see how this evolves. Let me just refresh that. No. We'll have to see if that KP7 continues. We might see a 7-pointer, definitely. So this is something we have to monitor, the seismicity globally. Don't know if this one is actually showing activity. Wait a minute, this cam isn't recording at all. Yes, now it is. There has been a little bit of activity. There was lava not too long ago, and you can actually clearly see it. These are all deposits formed. You can see some smoke over here. So this is definitely something you want to check. I will leave a link below along with those space weather scales. And regularly you can see actually lava coming out of this one. This is the Geldingaladur volcano and it's still active. So this brings me to the end of the video. I will cite a philosophical quote, another one, 38. The great man is he who still retains the innocent heart of a child. You know when they say that the child always speaks the truth, or actually the truth always comes from the mouth of a child. So basically, a child is always innocent, and a great man obviously has the soul of a child, basically of the heart, yes, the heart of a child. Okay, this is the end of the video. Hope you enjoyed it, and I guess we see each other next time. Oh yeah, I want to apologize for that weather video. Didn't really make it today, but then again I had to make 2 videos to cover these space weather events. But if all goes well, I will make it tomorrow. That's it.